Okay, so this is the first day back after you guys had 10 days off for spring break. That's pretty glorious. I hope you enjoyed it, but I know you've probably forgotten a lot of stuff. I'm going to start just here by telling you which problems out of today's homework we're going to do and not do. Okay, so I want you to cross off this whole right-hand side, 3, 4, 11, 12, 23, and 24. Then on this page, we're going to cross off 61, 91, and 131. And this one I am substituting in and saying you might want to use this instead of that. Let me prove to you they're the same. Do you get cross multiplying in two fractions that are truly equal will cause you to get an equal answer? Cross multiply those in your head quick. What's 1 times 2? 2. What's root 2 times root 2? It's root 4, which is 2. Do you get that those are the same thing then? But why do we care then? Why do we want to replace this with that? Because you know the 1 cosine is adjacent over hypotenuse. So 1, 2, root 3 triangle, or in this case, the 1, 1, root 2 triangle. You'd know that triangle. But if we use these numbers, root 2 and 2, do you know any triangle that's got root 2 and 2 in it? Okay. It is the root 2, and 2 triangle. What's it exactly the same as? 1, 1, root 2. Okay. I'm just trying to show you so that you don't get into this problem and go, I don't know what angle that is. Well, sure you do. It's the same exact thing as if you had 1, 1, and root 2, and you'd go, oh yeah, that's a 45, 45. Okay, so then some other problems I want you to do once I teach you how to do it. This is kind of weird, I know, starting with the ones that we're not doing for homework, but cross off that whole page. Next, I want you to do this one. And big surprise, there's a right triangle, and therefore you can do trig in this question. One of the themes of this whole second semester is we try to make you not forget any of the trig we've taught you. So we do a lot of review, and we even throw it on the tests. Like you can expect on your next test that it won't just have new material. It'll have stuff from the last couple chapters. You've got to keep it all together. Okay, so that one's assigned. I don't think you're going to be ready for any of these today, but you know what? I think I'm gonna cut out some problems I was going to do later, and I am going to assign a couple of these. I'm going to cross off these, and I am going to have you do those across the top, but I'm going to skip some ones later. Okay? Now, does anybody recognize a triangle that have a root 3 and a 3 in it? I don't. But what do you think would be exactly the same? Say it louder. 1 over root 3. And do you know a triangle, that has 1 as one of the sides and root 3 as one of the sides? Yeah, so then you'll know the angles involved. So don't forget, when you see one that's like kind of weird, it means you probably know some other one that's equal to that. Cross multiply, root 9 equals 3. It's true. All right, so anyway, and then that's it. That's all I'm going to have you do. I actually assigned some in the other hour. I regret that. Sorry, first hour, or in my case, second hour. But I'm not going to have you guys do any of those, because I felt like the lesson was too intense, too much to learn. All right, so now let me actually teach you some stuff. First thing I want to do, you can kind of look ahead and know the type of questions that we're going to do by, let's get to the very beginning of today. And I want to remind you about the lab. So this is page number 2. Okay, we're learning inverse trig is our new thing, but we have to finish up that lab. How many of you actually already got the Tide lab done? You were nice to yourself and you finished it. All right, nice work. Congratulations. Okay, so then there's a lot of you that are going, yeah, I just didn't get that done, which is fine. You didn't have to, because I'm not assigned. It's not due till Friday. Okay, and you know that sometimes if we were too busy on Friday with other things, I might even push it later than that, but I'm not promising that. It's due Friday. All right, so 2 seconds on the lab. Do you remember that the way I asked you to do it was to take 2 high tide numbers and then 2 low tide numbers right off that website so you get real data? Okay, and then what were you supposed to do? You're going to try to find a sinusoidal that goes through 4 points? Not really. You averaged them. Okay, so you average the height. Let's say that this is 18.1 and this is 18.3. Then you'd average them and you'd say 18.2 was your high. You want to get it down to 1 high and 1 low. Okay, and then you could do the same thing with the low tides. Let's say it goes down to 2 foot on this one and 2.5 or 2.6 to make it nicer on this one. You can average them and say it's 2.3 was your low tide number. Once you got 1 high and 1 low, do you get that you need the time in between them? Well, there were actually 3 time periods, and you can just average those. They're all around 6 hours because that's just how tides work. You got 2 high tides and 2 low tides in a day, so it's about 6 hours apart, but it's not as nice as 6. Don't forget, if it says 6 hours and 10 minutes in here, does that mean 6.10? No. How would you change that to a decimal so that you can average your tides or your times? I'd call it 6 hours and then, come on, you can do this. I heard over 60, right? So it's 6 and 10/60ths. And that can give you a decimal, which might be easier for you to work with than trying to carry around 6 hours, 10 minutes. You can call it 6 point whatever. Okay? All right. So then, sinusoidal. I'm going through this just so that your lab will be easier for you. Now, if I'm doing this for you right now, do you get that the logical time to do your lab would probably be tonight because it's fresh in your mind after I just showed you? Okay, I would do that. Otherwise, you're going to hate yourself on Thursday. All right, so y equals, and I need the amplitude here, and then I always use cosine, and then I use my b term here, and then I have a stretch of c, and then a move up of d. So a quick reminder on how those work again. Do you get that I want the amplitude, and that, what was that first thing I had you always figure out? What? The line, the dotted line that runs down the middle. Okay, and so let's say I had 18, oh, that was one of those little, my back was tweaked there for a second. 18 high tide and a 2 foot low tide, and I'm assuming we're going based on sea level there. Could something be above 2 feet above sea level? Yeah, that's what we're gonna. The numbers off that chart are based on that. So, all right. So anyway, 18 and 2 would average to. Well, you add them together, divide by 2, would average to what? 10. Good. And then, do you remember that the amplitude was this part? Which in this case would be what? So 8 goes there. And do you get that the shift up is this dotted line shifted up from normal? It's up 10 feet off of normal, so to speak. So that's a 10. Is all this ringing a bell? You remember me saying that you could put the x and the y axis like this anywhere you want, and therefore all that really matters right now is where the y axis is. And wouldn't it be logical to just start there so you don't have to do any shift? See what I'm saying? Now, if you really want to start somewhere else and then include a shift of this far, you can, but it's going to be harder for the person grading it to ascertain if you did that right. But I personally would just start and say my y-axis is here so I can make it not have a shift. Because you're allowed to start, I mean, you get time goes forever. There was no 0 in time. So you have to start somewhere. You have to put your bar somewhere. All right, so I can put it there. And then I won't have to worry about the shift. And then lastly, oh, the b term. I got to leave you some math to do, right? So you got a period equals, what's that again? 2 pi over b, and then you got to figure that out. Hopefully you remember how to take your times and figure that out. If you need to, you can go back and watch the video that I made at the very beginning when we introduced the lab. All right, so there's my reminder about the lab. Next thing I want to remind you about is that I did assign a thing called the True 20, which is some great practice for the ACT. And it looks like this, and if you have already lost yours, you may want to go take another one from my desk up here. I am going to take scores on that, but I want you to grade it off the key that is provided at my website, davidserver.com. Go look for the key for the true 20, and then grade it yourself. And don't be shy. If you got 6 out of 20, don't, like, is the stupidest time ever to cheat, because I'll know, because I'm going to give you another version of this test. And if you get way worse than you did the first time, I'll know you cheated. Just be honest. You only know 6 out of 20, that's fine. You can replace that score with the next time we take it. Okay? So be honest about how many you knew how to do, and that'll give you some feeling of your growth too. If you only know 6 out of the 20, and you can get up to like 17 out of the 20, you'll know you got that much smarter for the ACT. Okay, so this thing, if you need one, get one from me. Grade it yourself off my key online, and then be prepared to tell me that score tomorrow. Okay? All right, then, last thing, I need to do a little review. I'm thinking some of you might be as bad off as to not even remember where pi over 6 is, or where like 7 pi over 6 is. Okay, so I want you to take a moment and figure out where all the pi over 6's are and label them. Like, that's 1 pi over 6. If you forget, like, what are these again? Well, act like pi is like 180, because pi and 180 are in the same spot over here. 180 is pi. So act like pi is 180, and you just go, oh, it's like 180 divided by 6. Oh, yeah, that's like 30. Okay, so yeah, like 30-degree angles. Label all the pi over 6's all the way from 0 to 2 pi. I'm going to pause for a second while you give that a shot. All right, so 1 pi over 6 was there. 2 pi over 6 is here. Could you reduce that? Now, what's 2 pi over 6 the same as? Pi over 3. Okay. This is 3 pi over 6. Could you reduce that? Yeah, that would be pi over 2. Right? 90 degrees. Makes sense? From here to here is a 90-degree angle. All right. And then 4 pi over 6, 5 pi over 6, 6 pi over 6 is here. And, of course, that's the same as just pi. Right? Let's zero in on 7 pi over 6. It should have been right there. How many of you guys had that one right? Good. Now would you please draw me the triangle that goes with 7 pi over 6? And I want you to tell me the sine of 7 pi over 6. Just to remind yourself how that works. I'll pause for a second while you do that one. You labeled this correctly. You realized that that was a 30-degree angle. And therefore, this is a 1, 2, root 3 problem. But then you'd be making the most common mistake in circle trig. Negatives. Raise your hand if you remembered the negatives. Almost everybody. So therefore, sine of that is the opposite, from this angle's perspective, the opposite, -1, over hypotenuse, -1/2. Raise your hand if you had that one right. Okay. Now, do you get that I just gave you an angle and I wanted to know the sides? We never give you a problem that looks exactly like this because it's already got the angle and the sides. Something's got to be missing. Otherwise, there's no problem to do, right? This is the kind where I asked you for the sides. Do you get, we also have done some where I'd say, I don't know the angle, but I know the sides come out like this. And do you get that there'd be a theta in there? Sine of theta equals -1/2. And I already know the answer is 7 pi over 6. But that's a typical question where they have asked me for the angle. But wait, there's actually 2 answers to that question. There is 2 answers to that question. It really is. All students take calc. Do you get that this is only one of the places where sine is negative? Do you get that there's another? Would you please finish this off and find out for me what are the 2 answers for sine of theta equals -1/2? I already did one of them. I'll pause for a second while you figure out the other answer to that. Okay, hopefully you remembered that sine had to be negative, and there's only one other place where sine is negative. It's over here. And therefore, I really don't have to refigure out everything. I know it's the same angle. It's got to be a 30-degree angle there. And therefore, the answer, of course, isn't 30. This one wasn't 30. It was a whole bunch of 30s. Okay, so it was 7 pi over 6's. Well, this is more pi over 6's. A whole bunch of pi. In fact, if I go all the way, it'd be 12 pi over 6. So then you back off 1 and say that spot is 11 pi over 6. Raise your hand if you had that one right. Good. Do one more just like that. Let's not do sine. Let's do cosine. Cosine of some angle is negative root 3 over 2. Solve that one. There's two answers. Okay, let's see if you did this right. First off, oh, students, take calc. Who put those 4 little precious letters on there, virtual paper? Good. You really want to do that. It'll help you narrow it down. Cosine's negative. So it can't be here, and it can't be here, because those are places cosine is positive. There must be one there. And then, I don't know the angle, but I know that cosine is adjacent over hypotenuse. The adjacent side is negative root 3. Does that make sense? No, I must be putting it in the wrong spot then, right? Okay, so adjacent, oh yeah, here, negative root 3, and hypotenuse is 2, and that's a 1. What's across from the 1? 30. And if you said 30, you're wrong. If you said pi over 6, you're still wrong. It's a whole bunch of pi over 6s to get from here to here, and it's 5 pi over 6. Raise your hand if you had that one right. Okay, good. And there's another answer, though, and that's down here. Do I need to redo all of my triangles? Nope, it's the same angle. It's another 30, also known as a pi over 6, but it's a whole bunch of them, and therefore it's 7 pi over 6. So there was 5 pi over 6, and there was 7 pi over 6. Okay. Raise your hand if you would have had that right. Now, let me show you how today's stuff is just like that, with one little nuanced difference. You can write this. Do you remember me doing like this? Inverse cosine can take out cosine. Does that ring a bell? Okay. So if I do that, I got to do the other side also, right? Inverse cosine of that. But do you remember when we typed that in on the calculator, even though there were 2 answers, only one of them would appear? Okay, what I'm saying? Your calculator can only give you one answer at a time, for one thing. But also, inverse cosine isn't allowed to be in one of these 2 spots. That doesn't mean we can't answer the question that we had, the green one. But if I change the green one to this blue one and do an inverse cosine, that's what this new unit is about, is inverses, then one of them has to go. You're only going to get one answer on problems for this test, which is kind of nice in a way. There's only one answer instead of 2. But you got to know which one to throw out. What's your gut feeling? Which one do you think is going to get thrown out? 7 pi over 6 is going to get thrown out. It's true. Okay, now, why? Because it's bigger? Nope, it's not because of that. The inverses are only allowed in certain places. Now, remember telling you the first time that, like, oh, students take calc, that there's only 2 places where you can have a negative cosine, for example? That can only happen in 2 places, so you got to kind of like rule out the other 2, right? Well, there's only certain places that the inverses are allowed. I want you to write down, this is just as important as the whole ASTC thing. Now, for this unit, you also have to know where are the inverses allowed to be. And I'll show you why in a minute, but for right now, here's your list. Make a good one because you're going to refer back to it over and over again, this unit. The test on this stuff is coming in about 5 days from now, 5 school days. So that means I think the test will be about Tuesday of next week for this year. Anyway, about 5 days from now. So we don't have tons of time to learn this stuff. All right, so first off, inverse cosine, the one we just did a second ago, would have had answers here and here, but only one of them is allowed because inverse cosine is only allowed in these 2 quadrants. So I'm going to write it over here. Inverse cosine is only allowed in the A and the S quadrants, also known as quadrant 1 and quadrant 2. You'll have to memorize these. I can show you why in a minute, but now where is inverse sine allowed? Inverse sine is allowed from here to here. Inverse sine is allowed in the A and the C quadrants, also known as quadrant 1 and quadrant 4. And lastly, what do you think we're missing? Tangent. Tangent is just like sine, except it doesn't touch. On the ends of the little range where tangent lives, do you get that there are asymptotes around the tangent function? And therefore it can't touch the ends of the little zone where it lives? It's like it's in a cage with electric bars. Okay, the asymptotes. It can't touch them. So this is important that the other ones, they can touch. See the red one? It's touching up here. These aren't touching. Not touching, not touching. Okay? So that's inverse tan and where it's allowed to be. Okay. So then, how do we use that? We use that when we're doing a problem like this. Remember me saying how there was only one of these answers could work? What did I just say? Where could cosine be? Inverse cosine's only allowed in this zone from here to here. So that means it can't be here, and it can't be here. And that rules out this guy, and that rules out 7 pi over 6. And therefore the answer is just 5 pi over 6. And if you type it in on a calculator, and you ask inverse cosine, your calculator can do that. This one happens to be nasty because it has square roots in it and stuff, but if you ask it inverse cosine of negative root 3 divided by 2, it'll give you the answer of 5 pi over 6. If you have your calculator in degrees, it would say 5/60s, because pi over 6 is, no, 30s. 5/30s, which would be 150 degrees. So if you were to type this into your calculator, it would say only one answer. That one. Because the inverse cosine can't be in both places. Inverses have only little zones where they can live. All right, now let me explain why, just for a moment. It is true. You would not have to understand what I'm about to tell you to do okay on this next test. You just have to know where is inverse sine allowed, for example. But let me show you why it can only exist here to here. Why is inverse sine only allowed in there? Well, let me show you sine for a second. Do you get that sine is a wave that keeps going forever and ever in both directions? I'm talking about? Now, would you agree that sine will pass the vertical line test? That means it's a function. But can sine pass the horizontal line test? Not unless we limit it. The horizontal line test tells you that something can have an inverse. Do you get this whole unit's about inverses? It's not about regular sine. Regular sine can go forever. But inverse sine can only go from there to there. Because guess what it'll do in that little zone? It'll pass both the vertical and the horizontal line tests, which means its inverse sine, is a function. I'm going to show you that. Here's the vertical line test. Do you get it would pass the vertical line test? It would never hit twice. And it would have done that for sine, could go forever doing that, but it's the horizontal line test that it would have failed if I let it go further than it is. So do you get, if I let this thing go further, sine wants to keep going, right? Do you get it'll no longer pass the vertical line test, or sorry, the horizontal line test there? That's why sine's inverse is what we're talking about. The whole unit's about inverses. So sine's inverse will only exist between here and here. Okay? And therefore, that's pi over 2, and take a wild guess what it is over on the other side. Negative pi over 2. And that's going to blow some people away because when I go back to here, you may have noticed I didn't write anything down here. You normally would have thought I'd put a 3 pi over 2 there. But in inverse land, it's negative pi over 2. We agree that that's another way to say the same spot. You can get there by saying negative pi over 2. Why am I changing 3 pi over 2, which is another way to get there? If you go all the way around to here, that's 3 pi over 2. Why? Because your answers can not leave this little zone where sine exists. If I go outside this to try to get to where 3 pi over 2 is over here, it won't pass the vertical line test anymore. So I can't go over there. But my answers can stay inside here because this is where inverse sine lives. It'll only live in between negative pi over 2 and pi over 2. Another thought about inverses. Inverses are a reflection over the line y equals x. So the graph of inverse sine, we won't make you graph inverse sine. But if you had to, it's a reflection across this line. Do you get that that would go something like the green line? That's what inverse sine really looks like. That's why inverse sine can't exist outside of negative pi over 2 to pi over 2. All right, now, I haven't explained them all to you, but that's an example of why inverse sine can only exist between here and here. And for the amount of stuff I got to get through today, I'm not going to show you all the graphs of inverse cosine and inverse tangent, but it's the same kind of things would happen. Okay? They can only exist in these intervals that I've showed you. Yes, sir?
So if you're writing the angle for like inverse sine, will it never be bigger than pi?
It'll never be bigger than pi. You are correct. So if you have an answer, first of all, do you get that you can't even do any of the functions in here? I call it no man's land. If you're ever drawing a triangle there to do an inverse trig problem, you're doing something wrong. You're in an area where there's no solution. Okay? So do you get it can't be bigger than pi then? Your answers for this test cannot be bigger than pi as long as you're doing an inverse question. Remember, like I said, we're going to have some review questions from previous tests. Those can be bigger than pi. But if it's an inverse question, it can't be bigger than pi. And if it's negative, if you end up drawing your triangle down here and you get an answer of 30, it's not 30, it's negative 30. Do you get what I'm saying? If my answer came out to 30 degrees there, because that was a 1, 2, root 3 question, and it came out like all this, and I'd say, oh, the answer's, normally I'd say the answer was a whole bunch of pi over 6s, like all the way around to here. Nope, not an inverse trig. On the inverse trig, the answer would be negative 30, or if you wanted to use pi over 6, you'd go negative pi over 6. All right, so that's the difference. So now let me show you a typical inverse trig question. I'm going to clean this all up again because this is, I guess I could include that no man's land thing. This is the new thing to memorize, and it'll help you rule out certain quadrants. All right, so a typical question would look like this. Inverse tangent of 1 over root 3. Better write this one down, and I'm going to show you step by step what to do. First of all, that doesn't look like any problem we've ever asked you to do before. So, I want your first step to be rewriting it to like this. Tangent of theta equals 1 over root 3. Didn't we ask you to do questions like that before on a test? Yeah, we did. You've been tested on that twice. But normally there were 2 answers for that. You know, in the ASTC thing, there'd be 2 answers. So I just showed you a new set of rules for the inverses that limits it down so you'll always only get 1 answer. All right, so let's just answer it like normal. Like normal, you want this? Please stay with me. Copy this down. Now it's been a long lesson, but this is one good, clean example problem for today. So I'm going to get my triangle drawn in the right place. Tangent, is it positive or negative? This statement right there says tangent is positive, and therefore it's got to either be here or here. So I'm crossing off these 2. Then, immediately, remember that you are in an inverse problem. And where is inverse tangent allowed? Do you remember? Was it A, S, T, or C? A and C, but C's already ruled out, so it can't be here. Remember, that's no man's land. You can't draw anything there for inverse trigs. Okay, so then, I'm back to here. And now it's just like every problem you've done before. Tangent is TOA. Opposite over adjacent. The opposite side is 1. The adjacent side is root 3. I know this one. 1, 2 root 3. Oh yeah, this is 30. And therefore my answer is 30, except I should say it more professionally in radians. Pi over 6. The answer is pi over 6. I want you to notice that we just figured out an angle. When you see this, this is the problem saying, I want you to figure out an angle. Do you get they already gave me the sides? They wanted me to figure out what the angle is. And remember, there's always only going to be one answer because inverse trig is only allowed in 2 spots at a time. Plus, they can only be positive or negative, and that also rules it down to only 2 spots. You'll never get 2 answers for inverse trig. All right, you just get 1. Let's do one more like this before do you have a question?
Yeah, is that a final?
Final answer is theta equals pi over 6. You might be asking, why isn't there another answer where tangent is also positive over here? Well, it wasn't allowed. So there's no other answer. It wasn't allowed because inverse tangent's only allowed between here and here. That comes from that new chart I just gave you. Okay. So now, how does it get one step a little teeny bit harder? It's really, honestly, it looks much more complicated, but it's really not. It's really not that much harder. Do you remember me telling you on all difficult math problems, you always start on the inside of it? Does that ring a bell? You know, the nested parentheses, you always go to the inside, work your way from the inside out. All right. So then here's the inside, and then step 1. Let's see, Mr. Server said to rewrite it and make it look like the old problems we did. Sine of theta equals 1/2. You know how to do that, except you normally would have got 2 answers, right? But now we're only going to get 1 answer. So try this one. And when you're done, this is saying, I want you to figure out an angle. And then you're going to figure out cosine of that angle. If the angle comes out to like pi over 6, well, then you figure out cosine of pi over 6. All right, I'm going to pause while you give that one a try. Okay, now where you really be stewed is if you don't remember how to do what we did earlier, which was find this answer and get the 2 answers. Because if you can't do that, you're done. You got to remember how to do these. All students take calc, and this is where sine is positive, so can't be here, can't be here. Must be 2 answers, but why isn't there 2 answers? Because it's an inverse question. And where is inverse sine allowed? You have to go reference that other chart, and you'd find out inverse sine's only allowed in these 2 quadrants, and therefore it can't be there. You with me so far? Okay. Then sine is opposite over hypotenuse. Opposite, hypotenuse, that's root 3. And then, which ones are the, I guess it's the 30. But I should really say it more professionally. Again, once you get to calculus, you're just going to use radians almost all the time. Okay, so you won't even say 30. You just go right to pi over 6. Okay, so the answer is pi over 6. But that's the answer for this. This whole thing wanted an angle, and the angle was pi over 6. To get now I want to do cosine of pi over 6. No need to go draw a new triangle. The same old triangle is going to work. So what is cosine of pi over 6? I look at this triangle. It's already pre-drawn for me by myself. And I get cosine's adjacent over hypotenuse. Final answer, root 3 over 2. That was a composition of inverse trig functions. Composition means it's like built of 2 of them. If I had a composition metal, it's made of like boron and tin or whatever. It's a mix of the 2. This is a composition of inverse trig functions. How many would have got that one right? Awesome. It's your first one you even tried like that, and almost everybody got it. So that's cool. Now let's start the homework together. All right, so if I get to where the homework was, I'm going to pause while I do that. All right, so number 1. Number 1, the first thing it says is arc. I never mentioned this before, but that's the same exact thing as inverse. Okay, so when it says arc sine, that means inverse sine. I believe that it came from You're doing arcs when you're doing circles, and so it has to do with that. So we'll just leave it at that. For right now, all you need to know is that's the exact same thing as if they had said sine to the -1. They are identical. Okay, it's just a different way to say it. Now, my first thing was, I said rewrite this in a way you're used to. Sine of theta equals -1. And I always have told you if they only give you one side, they really gave you two sides. So you put it over 1. Now I got to think back to where in the heck am I going to draw a triangle in here with all students take calc. Where am I going to draw a triangle where the opposite and the hypotenuse are like that? Oh, wait a minute. That can't be a normal triangle because the hypotenuse isn't bigger than the opposite. So therefore, it's got to be at one of these spots. So many things to remember from trig, from circle trig. On those 4 spots, do you remember sine is y, cosine is x, and tangent is y over x. Good. So if I'm in sine right now, this is sine, which is the y. The y needs to be -1. So where is the y -1? Right there. But classic mistake would be to say 3 pi over 2. Because in inverse trig, that's not 3 pi over 2 because there's no answers that are bigger than 90. So how can I say that without making an answer bigger than 90? Negative pi over 2. Hardcore math. So many little things to remember. All right, let's do the next one, number 2. This one shouldn't be as bad. It's going to be kind of normal. It's not a quadrantal. You can draw a triangle for this one. Figure out where you should draw the triangle. And we really want you to get number 2 done right now in class. Finish it up. It'll take us right to the end of the hour. All right, did you know that since all students take calc, this sine is negative, I would have you rewrite it as sine inverse, sine of theta equals -√3 over 2, and that makes it negative, so it can't be here and it can't be here. Then there's 2 spots, but wait, Mr. Server said there'd only be one answer, so where is inverse sine allowed? Oh, it's only allowed here and here, so I got to throw that one out. The answer must be in here, and sine is opposite over hypotenuse. Oh yeah, the 1, 2, √3 triangle. I know that one. And what's let me see, the one's across from the 30. That means that's a 30. That's the important one. That's a 60. But I got to say it professionally, it's pi over 3. No, not 5 pi over 3. Remember, no answer is bigger than 90. Or sorry, no answer is bigger than pi. Negative, what's 60 the same as pi over 3? So negative pi over 3. I know, this is challenging stuff, but you got to remember the context. You've had 10 days off of math. You've forgotten some stuff. This isn't that bad. You can do this. I've cut your assignment down quite a bit off of what it would have been, so please respect that and get the ones done that I gave you. There is an answer key that will be posted. Actually, it's already posted, so this is doable. Don't forget the lab's due Friday. If I were you, I'd get it done in the next couple days because they just reminded you how to do it. And get your true 20 graded off the key that's online to get me those scores hopefully tomorrow. That's all I got for you for today.